Hi everybody. In this video we are going to talk about the Planetary Terrestrial Analog Library, the PTAL project. The PTAL is a project that has been funded by the European Commission through the Horizon 2020 program, and in this video we are going to talk about the current and forthcoming mission to Mars, and we are trying to explain why the analysis of terrestrial analogs is so important for the exploration of Mars and other planets. Then in the next video we are going to talk more in details about the PTAL project and the way how this PTAL database will support the planetary exploration missions. And when I need to talk about the exploration of Mars, I always start by showing this image, which represent all the main missions that has been sent to Mars. As you can see, those missions are placed in chronological order, and at the beginning, the exploration of Mars was basically a competition between the United States through the NASA and the Soviet Union. But then, with the pass of the year and the decades, more and more countries and space agencies try to join the exploration of Mars by sending their own landers and orbiters. Now, this image is not completely updated, but if we're going to see in the past few years, there are several additional missions that have been sent by Iran, by India, and there are future missions that will be sent in the next few years by the European Space Agency and from the Japanese Space Agency. So, as you can see, the reason why we are sending all these missions and we're sending more and more missions to Mars is because the more are the data we are collecting from the surface of this planet, and more interesting are the results we are obtaining. And beside characterizing the mineralogical and geological units of the planet, what is more interesting is that what we can get from those information is that we have quite solid clue that maybe in the past Mars could host the optimal condition for the proliferation of life. So most recent missions had actually the purpose to find those traces of life. Um, but when I'm talking about Martian life, several people often find difficult to understand that actually a red planet that looks like a gigantic desert could actually host life. But what most people doesn't know is that billions of years ago, the surface of Mars was looking completely different from what it's looking now, and was actually looking quite similarly to our modern Earth. Actually, we know, thanks to the data collected through those missions I showed you before, that Mars probably had liquid water on its surface. It has it has had an atmosphere rich on oxygen, and it had a magnetic field. And those are the ingredients that we need for life to proliferate, at least on Earth. But then what happened is that around 4 billion years ago, Mars the inner core of Mars got more cold. The solid core, the liquid metallic core became solid, and then make Mars to lose the magnetic field. So by losing the magnetic field, the surface of the planet was exposed to solar winds um, and other radiation from space, which slowly make the atmosphere and the liquid water on the surface almost completely disappeared. And of course, so what we know is that if we are going to Mars and we want to find traces of life, most probably those are traces of life that are the remaining of past microorganisms that maybe were living on the surface or the subsurface of Mars billions of years ago. And of course, to find those traces of life is not so easy, and that's the reason why we need to send very several different kind of missions. and different kind of which are equipped with different kind of analytical instruments. So as you can see here, this picture show the different kind of rovers that have been sent to Mars by NASA. And what you can see is that starting from the Sojourner rover sent in the 1997 to the Curiosity rover and the Perseverance rover that has been sent in 2021, the size of those rovers strongly increased. But beside their size, what is more important that is that the newest rover are equipped with very advanced analytical instruments, which have been designed exactly with the purpose of detecting those traces of life on that maybe are potentially preserved within the mineralogical matrix of the geological samples that we can find on the surface or subsurface of Mars. As I said before, there are new rover mission that has been sent to Mars. The one of the most important one for sure is the Mars 2020 mission that has been led by NASA. And as most of you probably know, the Perseverance rover landed on Mars on February 2021. And the main objective of this rover is to characterize the composition of Martian rocks and to select and store the optimal sample for future for the future sample return mission. So the optimal sample the Perseverance rover is gonna catch are the samples where we think we could find potentially traces of organic compounds, and the selection of the samples is driven by the results collected by those analytical instruments. So as you can see, we have X-ray fluorescence spectrometer, and then we have Sherlock, which is our UV Raman spectrometer, and SuperCam that characterize the rock of Mars remotely by combining Raman, VSIR, and LIBS analytical methods. So what is important to underline here is that this rover is the first one that has been sent to another planet and that is equipped with Raman spectrometers. So this is the first time the Raman spectroscopy is used outside the terrestrial domains. And similar to the Perseverance rover, the Rosalind Franklin rover that the ESA and Roscosmos are sending to Mars in 2022 are also equipped with several kind of instruments that has the purpose of detecting traces of life of Mars. So in this case, we have this NIR spectrometer that will work together with the Raman spectrometer, and the geological information that we get will help selecting the optimal subsurface samples that will be analyzed by a gas chromatographer. Also, in this case, this is the first instrument, the first rover that is equipped with this NIR instrument that is capable of performing molecular maps, and also this is the first Raman that is capable of performing multiple point of analysis on powder samples collected from the subsurface. And considering that both the Rosalind Franklin rover and the Perseverance rover are equipped with these new instruments, what is important is to try to understand what kind of information we can get from those analytical systems. And to do so, what we need to do is to perform experiments in the laboratory on Earth. And to do representative experiments, what we need to do is to perform analysis on samples that are somehow similar to the geological units that we are expecting to analyze on Mars. And likely on Earth, there are not a lot of places where we can find geological materials that are similar to what we're expecting to find on Mars. And but those locations and those materials are called terrestrial analogs. So to analyze terrestrial analogs is a cornerstone tool to optimize the scientific outcome of those missions, the future missions that are about to come. And that's the reason why we have the PTAL project, which purpose is to build an analytical database of terrestrial analogs that has been selected all around the world and that have been analyzed by using different kind of spectroscopic instruments, both laboratory commercial instruments and simulators and spare models of the analytical instruments that are on board the Rosalind Franklin rover. So as I say, in the next video, we're going to talk about more in detail about the PTAL project. So see you in the next video. Thank you.